Okay, great. So, hi everybody. I'm really delighted to be allowed to present this to you. So, thanks a lot for having me, and thank you, of course, to the organizers or the organizer, Lukas. I was really delighted that you asked me if I would like to join. And I don't know, maybe you already know, but everything will be shared. So this also applies to all the material you will see now, like the slides. And we later also go through some templates, and this will all be shared on Zenodo. So you don't have to note anything down. You can just listen me. Okay, great. Before I start content-wise, I would like to do a little advertisement for our Igor group, which is the interest group for open and reproducible science. And as the name already says, we're interested in open and reproducible science. So this might be something also for you. We are part of the German Society of Psychology. We were formed in spring 2020. We have now over 100 members. And yeah, we do different activities. For example, we are a member of the German Reproducibility Network. We have like different projects, for example, on precision in human neuroscience. We do 2 online hackathons a year, and we also have other projects about data transformation, power analysis, EEG analysis, and sustainability, for example. We are also present at the Psychology and Brain Conference here in Germany, which is a real, kind of important conference in biopsychology. And we also offer BITS consultation hours. I don't know if you know the BITS format. It's a specific format for fMRI data. And yeah, if you want, you can join these hours. And of course, you can join us. You can follow us. You can connect with us. We are always happy to welcome new members. So just drop us a line. Okay, now we start with the content, what I would like to do today. So I would just present you the idea of reproducibility or of reproducible writing. And when you think about getting started, I will give you some pros and cons. We will also talk about some prerequisites. And then we do, I will guide you through a Markdown, R Markdown demonstration. And we'll tell you some things about useful packages, where you can share your data and your code. I will spend some words on collaborative writing and give you some more reproducibility stuff and also some resources. Okay, let's start then. So what does reproducibility actually mean? It means that we want to make the raw data, the code and the documentation, and also the computational environment available and accessible to others. So today we will focus on code and documentation. And our ultimate goal is that any person who has the code and the data can reproduce our analysis, basically, but in our special case, also the published manuscript. So this is our goal at the end. And when you think about integrating more reproducibility in your scientific life, these thoughts might help you a little bit. So there was an investigation of Adner and colleagues in 2021, and they tried to reproduce 232 statistical results in psychology. And what happened was that they could not reproduce 30%, which is a lot, I think. And also 7% of the results were not significant anymore. And they wrote that it was really time-consuming trial and error work. So they really had a hard time, or in other words, it was just a pain in the ass. And Adner, or the study of Adner, is just one example among others. So there have been other attempts with similar conclusions. But of course, there are also more reasons why reproducibility would be a good idea. It's a very important prerequisite for robustness and replicability, which might be also something for you as you're here at the Law of Replications Week. So only if your results can be reproduced, they can also be robust and replicable. And it also helps to avoid transcription and rounding errors. So yeah, if you copy and paste your results from R to Word, you probably know that it's a rather error-prone process, especially when you're rounding. It makes you transparent at a maximum, so everyone can see what you have done. And it's also a very good protocol for your future self. So you really know what you did, which might be important in the future. And of course, there are different scenarios in which reproducibility can be really, really nice. For example, imagine you have just finished your manuscript and then you have to exclude one participant, which is, yeah, really, really bad. But when you wrote your manuscript reproducible, it's not a problem at all, actually. It's, well, done very quickly. Okay, you need some prerequisites to start. This is the short list. You have to install R and R Markdown versions. The latest versions would be good. You need packages, R packages, especially CiteR and Papaya from Frederick Aust. Papaya is the package we are mostly working with. It's very convenient because you get publication ready APA 6 styled manuscripts at the end, which is really nice. Then you need MikTeX, some LaTeX stuff, and Zotero, which you probably know, I guess. It's for literature, and we also need a special plugin for Zotero so that Zotero and R can connect in a very convenient way. So this is what you need in short, but I will also provide you with a more detailed explanation in the Zenodo things I will share. There will be a document, and in that document, I'll explain that in more detail. Okay, and now we already switched to R Markdown, and at this point, I have to thank Julie a lot because she's a real expert in that field, and the templates I'm using are, well, yeah, more or less based on her work. So thanks again, Julie, for that. That really changed my life. Okay, then I'll stop here for a second. If you already have any questions, you can just ask. Otherwise, I'll switch to R Markdown. No questions? Okay. Then I share my screen again. Okay. Before, oh, that's nice. Okay. Didn't start it again. Before I start talking about R, I wanted to show you my structure because I always set up a specific folder, or I have kind of a specific structure in my folder, which I found very useful. So we have, first of all, and that's very important, I create R projects, which just live in the folder where all your manuscript files are. This is the R project. I will show you in a second how you do that. You can do that very quickly. Then I have a folder with my data. And only the data is here in that folder, and a folder for figures, for the ones that are not created within R, for example. Then I have a folder for my scripts that you can put like cleaning scripts, data cleaning scripts, or whatever you need. And then we have all the manuscript files. Well, these are the manuscript files. You probably know them by name, like introduction, methods, results, and so on. And we have a main file, and this is our so-called parent file, in which we define like all the settings and metadata. I will show you in a second. And the other ones are the so-called children files. And as I said, this is our R project, and these are bib files. So this one, the first one is from Zotero. This is, yeah, I got this from Zotero, let's say, and the other one is created within R, which I will show you later on in the methods section. This is also very convenient. And the R project has the great advantage that R knows where it has to search for things. So you don't have to set absolute path, but you can set a relative path, which is also very helpful when you want to share all your things, because then you can share the whole folder, and R then just searches within that folder. So if anyone else gets this project in a folder, it all can be done very easily. You don't have to adapt all the paths. Okay, this is the folder, and you create the R project, like here, file, you say new project. Then you can decide if you want to have a new directory or an existing one. And you can also choose version control here. It then uses Git and GitHub, which is also very nice. But I don't go into detail here, but just letting you know. And you can, just a second. Yeah, you can just browse here where you want to put it and create the project, and that's all. And it simply lives in the folder, as I showed you. Okay, then let's start with the main file. So as I said, this main file is our parent file, and it starts with a YAML, the so-called YAML. This is a metadata section, and here we can specify a lot of things like the title, author, and so on, and also which kind of manuscript we want to have in the end. And we just go through it. So we can here specify the title of the manuscript and also a short title, which will be shown above in the Word document. And then we have the authors, the affiliations, which can be defined here in more detail. Do you see my mouse actually? Oh, I only see Lucas. Can you see my mouse?
Yes.
Okay, great.
It's difficult if you don't move it, but because it's black on black for me, but if you highlight something, then yes, it's easily
Okay, I see.
visible.
Is this actually, can you read this well? Or should this be a little bit bigger, like the font and stuff?
I can, but if you want to go sure, maybe press Control and plus.
Yeah,
So yeah.
okay. Yes, okay. Then you can add, if you're the corresponding author, also your address and email. And you can also add the role you had. So what was your kind of contribution you've made? And you can also add an author note, of course, your abstract, important keywords. You already specify here the bib files and also the appendix. And then you have some settings like floats and text. This means that the figures are shown in the text and not at the end of the manuscript, which might be also the case if some journals require that. So you can already define this here. Then you can add a figure list, a table list, and so on. And you say here that we want to have APA 6. There is already APA 7, APA 7 version, I think, but as far as I understood, it's still under development and not as stable as APA 6. And we want to create a manuscript, and we want to have a Word document. Okay, now we are entering the first code chunk. I don't know how familiar you are with R Markdown, but in R Markdown, code live in chunks mostly. So between the chunks, you can just write normal text, but code lives in chunks. And these chunks always start with 3 apostrophes and curly brackets, a lowercase r. And then the chunk or each chunk has to have an individual name. This is also very important because the document is not rendered if not every chunk has an individual name. And then you have some setting options. I will explain you in a second. Yeah, as I said, this document is mainly there to initialize everything. I used to start with deleting everything, but this is, of course, a matter of taste. I like to start from scratch every time, but well, yeah, it's of course up to you. And then we set some global chunk options, and this is the important difference. So these are global options. That means that they apply to every chunk in the whole or in all manuscripts, but you can also change them locally. Echo equals false means that you don't want the chunk to be printed in the rendered document. Well, we mostly don't want this, usually in manuscripts. Then include equals false means that the results of the chunk will not be printed in the rendered document. And now, for example, if we want to, or if we create figures in R and we want to show them in the manuscript, we need to include them. So this would be a case where we would set the code chunk to, or the include option to true. But I will show you this later on in the results section. But I do this globally here, everything to false, because this mostly applies to all other chunks. Then we set a seed for the random number generation. And of course, we want to be reproducible and replicable. So we set the seed, but you can, of course, choose here any number. Then in the next chunk, we load the packages. I always recommend to note down for which the package was used. This is also very helpful because sometimes you get lost in all the packages you tried out. Then we load the data. I will just quickly show you the data so that you know what we're working with. It's skin conductance data from a free conditioning paradigm. It's in the long format. So you see that the first person here has several entries. We have then the age, sex, the trial number, phases. We had different stimuli. This is the amplitude of the skin conductance response. And we also have some questionnaire data. Okay, this is our data frame. And then, as I already said, we have different child documents. And this is already the first one, the introduction. And this should be specified here, but nothing else in this chunk. This is also very important. But if you do it, R would tell you. Okay, then we start with the first manuscript file, which is the introduction. I used to write in the source code, but I know that many people also write in the visual code, which looks a bit more maybe user-friendly. But actually, I wanted to start with saying I always start with a short introduction, what this file entails. I mean, for the introduction, this is not so important, but later on for the results section, for example, it's very helpful to know what kind of structure the file has. And yeah, then we already start with some text. This hash means this is a heading. When we have a look at the visual code, you also see that this looks differently. And the nice thing in the visual code, visual mode, is that you have some options. It's a little bit like a Word user interface. Well, not really Word, but you have some functions. For example, you can bold the text or italicize the text. And when you have a look at the source code, you also see how R did this. So you added basically asterisks, two for bold and one to italicize. And here is one of the most interesting things for the introduction, probably citation. In R, you can use the at, and I use the author in lowercase and the year, but this is something you have to specify in Zotero because R uses the citation key that you specified in Zotero beforehand. And you can add the citation inline or just in the sentence or at the end of the sentence. Then you use it. You use the same, but in square brackets. Yeah, and that's it. I will show you in a second how this looks in Word, but first I wanted to show you some more things what you can do here. I already showed you bold and italicized text. You can add, for example, some bullet points, which can be done here, and whoopsie, also numbered list. As I said, you can always have a look how it looks in the source code. Not very interesting so far. And you can insert, this is also, I wanted to show you, you can insert citations also, well, you can just write them down or you can insert them by this insert button and say here citation. And then it opens your library. This is also very convenient. Then you can choose here the one author or more and also say if you want to have the citation in text or not and insert it. And that's it. And yeah, you can insert a lot of other things, for example, tables, like very simple tables. Let's say it's a 3x3 table. You can add here headers for the columns and also then just fill it. And in the source code, it looks like this, also very simple. You can also add figures here. You've already seen that one in the figures folder. You take that one, say, this is, you can also then add the caption. Okay, and then it's already in. You can specify here the width and the height. And yeah, then you already have your first figure in your manuscript. So it can be done very quickly also. And if you want to code it, it looks like this. So, and you see here the path. So it's not a long one because R know where it has to search. You just have to tell it that the figures in the figures folder. Okay, what else would I wanted to show you? You have the caption and you can also add comments, which will not be shown in the manuscript, but this might be helpful for collaborative writing. But I also come back to this later on. And what else do we have? You can also add footnotes, and this is also there you have also the table options and the format style. Yeah, so it's a bit like a word user interface. Okay, then we save this one, and now the interesting part happens. We need the document. And we do this always from our main file. And this is the button to do it. We just simply click on it and then it does not find the citation I added. Okay. Sorry, Rainy. Let's try it again. Okay. It worked when I tried it before. I think I did not change anything. sometimes it's the problem that the Word document is still open, but this is not the case. But this is something you always can check. Okay, I don't know why this happened. Okay. I don't know what the problem was actually, but now I can't unfortunately show you the table and the things we inserted, but obviously there was a problem with, I don't know, the table or the figure. I tried this out before it worked. It's R. Okay, but this is now the, whoops. This is now the document we just rendered. So you can see this is the short title we defined and the long title, the authors, affiliations, author note, and so on, abstract keywords, and the introduction. And the citations now look like this. And at the end of the manuscript, we also have the reference. So this is also added automatically, which is really nice. The references will be added before the appendix, but this will be done in the discussion section. I will show you later on. Okay, we close this again so that we don't forget to close it and move on to the methods part. As I said, you can add the R references very easily. So all the packages you use for creating this manuscript will be in there. This is a really convenient function. And in the text, you can then just later on say what for data analysis and so on, we used this object. And I will explain you this inline code now. But before I wanted to say, of course, this is also a matter of personal taste, but I always do it like this. I do all the calculations and stuff in the first part of the manuscript, so in the upper part, and in the lower part, I add all the text. For me, it's the most easiest thing, but you have to, well, just try it out. Find your own style, maybe. But I would start with the calculations. For example, we calculate the age of the participants and also the standard deviation. And when we then start with the text, this is also something this is like a header on the second level. So the more hashes you use, the lower the level of the header. And then, as I said, this one is so-called inline code. So you can calculate in the text as well. You don't have to do that in chunks, as I said before, actually, but you can also do it in the text when you use this accent and then the lowercase r, and then you can insert any command. Like we calculate the number of the participants here, or you also may add the object. So we assigned the calculation of the mean to this object, mean age, and then you can refer here to this object. Okay, then I would say we'll have a look again how this looks in the Word document. Well, I hope it works. And we knit this again from here. I forgot this one. Then it will be rendered again, hopefully. Yes. Okay, there it is. You already know this one and that one. And now you see the methods part here. and there has been code beforehand, but now it's numbers. So we have 120 participants and a mean age and a standard deviation of the age. And we now know what packages we used for creating this manuscript. So yeah, and of course, these packages are also listed here in the references part, which is also really nice. Okay, now we have the introduction and the methods. Oh, it would be so nice if every paper would be quick like that. Okay, let's move on to the results part. As I said, maybe here it's the most important thing to comment on what you did. As I said, I always start with calculations. For example, let's say we want to calculate a t-test if males and females are differing in their skin conductance. And we aggregate the data, we test for the homogeneity of variance, we then calculate the t-test, and we see that there's no difference between the sexes. And we also calculate Cohen's d, and we already assign again these names, or we assign this t-test to an object so that we can later refer to it in the text when we want to report it. And now we can also do a nice figure, maybe a bar plot to illustrate our results. So also we can see here that the females and the males do not differ. And maybe we also want to add a regression. We want to know if the questionnaire data has an impact on our SCR. And here we already use the APA print function, which is also a very nice function from the Papaya package. This will make it very easy to show this regression result in a table. And then we start again with the text. So in the results section, blah, 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 we do some calculations again. We calculate the mean and the standard deviation, and then we start to report the t-test using print t-test. Of course, we can also round here, as I said, so you can really use this as very small code chunks. And now, pretty cool thing is that you can also add cross-references. So you don't have to do this by hand. This is also a very error-prone process, as you might know. So you refer to one figure, have a look at figure 2, and there's no figure 2, for example. This cannot happen writing this in R Markdown if you use the cross-references here. You just say the backslash and then add ref, and the one for figure is fig. And this is the name of the code chunk. So, and I use this code chunk to insert the figure. So you have the results part or the text here, blah, 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 and then you want to show the figure. And now this is why we say here locally include equals true. So then the figure will be shown in the manuscript. And as I said, every code chunk has a name. This is the name of this code chunk, and this will be referred to in the cross-reference. So this can happen even afterwards. So the code chunk can show afterwards, but R knows where to refer to and now knows this is our first figure. And we can also specify here the width and the height and also a figure caption. And then we just say, print this bar plot. And this is the name of the bar plot we specified beforehand when we run this code. Okay, now we have the plot, and we can also now add the table, and we can also include a cross-reference to the table. This is pretty much the same, except that we don't say fig here, we say pub. So R knows that we are referring to a table, and that R provides the right number to it. or assigns the right number to it. Okay, and then we add the table using APA table, which will make a beautiful table. I will show you in a second. And also we can also specify a caption here. Okay, I think we are again ready to knit the document. I hope it works. Looks good. Yeah, and there it is, opens. Okay, we know this. And now the results, as you can see here, the mean and the standard deviation we calculated. And this is the result of the t-test. We refer here to figure 1. And this is our figure with the caption. Very big. Of course, you can make it a little bit smaller. And then also cross-reference to our table. This does not have a number. I'm not sure about that. But as you can see, also the table is also already APA styled, which is very convenient. Yeah, okay. What is also very nice, automatically there will be a folder now in your folder with the figure you just printed, and you will have it as PDF and PNG, which is also a very cool thing if you have to share it separately when you do your submission. This is also nice. Okay, and yeah, the last part is very easy. This is the discussion. Nothing really new here. Besides this, maybe there is this little code thing that Frederick Aust wrote that with the aim that the references show prior to the appendix in the document. And that's all. That's all it does. Okay, we will have a quick look how this all together looks at the end. Okay, we have the introduction, methods, results, and then the discussion, and now the references are in the right place. So discussion, references, and the appendix. Okay. I would say now you're ready to submit. Almost. I would go back to, yeah, great, Lucas, thank you. I would go back to the PowerPoint presentation. But do you have any questions regarding R Markdown? I hope it was not too quick in general. No questions so far? Okay, then I'll move on. I just want to quickly show you some useful packages for figures. I usually use ggplot, which is very helpful. I guess you all know it. What is also really helpful if you want to combine figures for publications, these are useful packages like Patchwork, Cowplot, and ggpubr. I used to use Patchwork because I've found it most convenient. For tables, there are also a lot of packages. I used Cable Extra a lot, but at the moment I use Flexible. As the name says, it's really very flexible. It's a really nice package. And also, as I already showed you from the Papaya package, there are also some built-in functions. There are a lot of other packages, but one I also found very interesting is articles. This has already some templates in it for different journals, but I never tried this out, I have to say, but maybe you want. Then when you went to share everything, like all the code and your data, we do this usually on Zenodo because I think it's very easy to handle. And also the files get a DOI, so you can cite it, and the repository is permanent. Of course, you can also use OSF, which is also good. I found it a little less user-friendly, but this is also like a matter of taste. And GitHub, of course, is also a great repository to share your code. But as far as I know, it's not permanent. But we use it a lot for version control. But yeah, I'll go back to that later. Okay, let's do a quick reality check. So I have to say there will be pain. So not everything will work right away. You have to Google a lot, try things out, and you will encounter several problems. So it will take really time and effort, but you will find a lot of solutions out there, promised. And it's also getting more and more. And as I said, it's really worth it. So it's a very good protocol for your future self. So mistakes are a lot easier to spot and correct, and others can learn from you. You can learn from others. And I also think it's really fun and rewarding. So in the end, when you knit the whole manuscript, it's a really cool feeling if it works. And you always have to keep in mind that reproducibility is not a dichotomy, it's more a continuum. So it might be the ultimate goal that everything can reproduce from your raw data with just clicking one button. But I think everything is better than nothing can be reproduced. So I think it's good to start just somewhere and then see how far you can get. Okay, some words on collaborative writing. So we simply use Google Docs and transfer the code to R Markdown. So we already write here, for example, the introduction in R Markdown manner. So for citations, for example. And of course, we do the analysis and things like that in R Markdown. And then we copy the tables and figures back to Google Docs so that we have one place where everything is easy to understand. And it's not so much work. For us, it works well, but there are also some packages you might want to try out. For example, there is RM Drive, with which this transfers the code back and forth between R and Google Doc. And there's also the redoc package, which does the same between R Markdown and Microsoft Word. Okay, some more reproducibility stuff if you don't have enough right now. As I said, we use Git and GitHub a lot for version control. And with GitHub, you can even revert the entire project to a past state. And renv is also a very useful R package because it records the version of your current R packages and makes it very easy to install them elsewhere. So when you want to share them with others, for them, it's very easy to install the packages you used. So these are the two we use. But beyond, you can also use Make, for example, and Make documents how different parts of an analysis and a corresponding report relate to each other and in what order they have to be executed in a way. So it's there for managing dependencies. And Docker serves as a container, so it's like a virtual machine with specific versions of your software and libraries. And using these things together, so R Markdown, Git, GitHub, Make, and Docker for a reproducible workflow is very well described in a paper of Aaron Peikert and Andreas Brandmeier. I also posted this along with other resources. Okay, and there's also CodeOcean and Binder. I cannot also not here talk so much about these because I never used them, but as far as I understand, you can upload your code there, and then they track the version of your software and so forth, and everything can be rendered online, and others can even change the code and see if that changes the results. But of course, the changes are only for themselves. Okay, then I have some resources for you about reproducible manuscript writing and also about the workflow that I mentioned, and again on R Markdown, which might be very helpful, and also something for your coding style. Okay, these are the references of the R packages. And with this, I would like to thank you again for listening, for your attention, and also again to you for setting this up, this Love Replications Week. Lucas, really great. And yeah, if you want to get in touch, just contact me. I'm always happy to help with getting more reproducible. Thank you.